Okay. Good afternoon, everyone. On behalf of agricultureinformation.com, I like to invite the speaker, Mr. Vinay Yadav, who will talk about developing cost-effective and efficient green hydrogen-powered drone. I now request the speaker to begin. Thank you.
Thank you so much, ma'am, for inviting me for this call and giving us opportunity to present about cost-efficient manufacturing of hydrogen drones or agriculture. First of all, I would like to introduce about our organization, which is working since 2021, Visron Private Limited, for the benefits of marginal farmers by providing them drone as a services of pesticide spraying. So we were one of the first organization across world who were developing one of the world's first hydrogen powered agriculture drone. And through this, we are solving one of the biggest problems in the pesticide industry, which occur every year through India and also globally, which cost 50,000 crore rupees to Indian farmers and $220 billion globally to the farmers across the global. So, why this is happening? Because the conventional spraying method were not sufficient to spray during the pesticide spraying cycle. And apart from that, the spraying services which were given by the drone organization right now, so those organizations currently focusing on sales of the drones, and along with this, the organization, like including our organization also, so we need to charge at least 500 to 700 rupees per acre. Reason behind that, because batteries were having a short flight time, and due to that, we can't able to fly a drone more than 15 to 20 acres of a spray. And also the life cycle is very short, that there is a recurring investment on the batteries every spraying month of around 10 to 15 lakh rupees. So due to these issues, and also majorly these battery power drones and the batteries as a power system, which act as a major component of this whole drone anatomy, comes from the border touching countries. So due to this, there is not a proper infrastructure and supply chain available. And majorly, these drones are manually operated drones. So, in that, you have to get a drone pilot, and in the tier 3 area and the rural area, getting a drone pilot and also having a good amount of a skill set, it's not a easy task. So, after working as a service provider for around 1.5 year, we got to know that we have to solve this all challenges if we have to serve to the Indian farmers. So we decided to develop a hydrogen powered drone through which we can give a value-based we can generate a value-based revenue model through which we just not only give our services to the farmers, but we also have a sort of value for the farmers in the form of saving of their investment, which is happening on the pesticide, on the services. So that's why we were only charging 100 rupees per acre, which is even lower than a farmer himself or herself was going to the farm and doing the spraying services manually or by the drones. So here, we were providing end-to-end solution, which not just only include the spraying services with our hydrogen-powered drones, but it also include the refueling, the maintenance, and like everything. So they don't have to worry about regarding like when the drone is going to come, when the drone is going to spray, how it's going to spray, if there any damages happen, so how we're going to repair and maintain it. So all these things were going to handle by our organization. And last but not the least, our drones are fully autonomous. So This allows us to eliminate the reliability of the drone pilots, and we can fly 10 to 15 drones with a single ground control software. So that is also one of the advantages we have in our hydrogen powered drone. So this is the drone what we have developed. It has a 16 kilo payload capacity, and within a single day, it can cover 80 to 100 acres of farm by pesticide spraying. So if you see, it is significantly higher than any type of spraying method right now available in the in India, and not only in India, globally also. And also, we have developed the whole technology indigenously in India using closed cathode liquid cool system. And that has allowed us to make our drone efficient enough and economically very viable from the perspective of market need. Because currently, if you see globally, all the hydrogen powered drones which were developed for the other applications, they have open cathode liquid cooled or open cathode air cooled hydrogen fuel cells, which allow drones to take only 5 kilograms of payload. So there, our organization's USP and our research and development USP come up as an exception, that we have developed the lightest hydrogen fuel cell ever developed for any kind of drone application. And along with this, the operational cost is only coming 22 rupees per kilowatt hour. So if I compare it with any kind of battery powered drones, which I'm going to go do in the further slides with our competitors. So you can see how much efficient and how much economically viable it is from the perspective of farmers' usage. And currently, and there is also one of the challenges we are solving, which is of refueling time. So if you see, all the battery powered drones currently taking at least 30 to 45 minutes to get it cooled down and to recharge them, and again to utilize those batteries again. So here we don't have to do nothing like that. We just need to refuel the fuel with the like the hydrogen tank, which can be done within 5 minutes only. So there is a time optimization also we were able to achieve with our hydrogen technology. So this is the video. If you allow me, I can show you. So this is the drone what we had developed, and currently you can see on above there is a 12 kilowatt of hydrogen fuel cell, and there is a tank, hydrogen tank, which can carry up to 7.5 kilograms of hydrogen gas. And here the green hydrogen is going to make a revolution in the Indian farmer ecosystem. The reason behind that, because the green hydrogen mission of across through around 2030 is to get the green hydrogen per kilo cost is less than $1. So you can imagine how much economical it's going to be in the future when the green hydrogen production is going to be at a very large scale, and the cost is going to be less than 90 rupees. So that level of sort of economical viability we were getting with our hydrogen technology. As already you are aware, companies like Reliance, Acme Group, they have already establishing gigawatt level of green hydrogen production plant across different states of India. So that is one of the things which we were achieving. And now, as I told you earlier, that the competitive analysis, if we do with our competitors, so you can see that on all the parameters, which include flight time, which include fuel cost, which include life cycle of the power system, and the most important thing, which is acres which we are covering per flight. So 60 minutes of flight time we were getting, which is significantly higher than any battery powered drone. Apart from that, the fuel cost only 22 rupees per kilowatt hour. So if you compare it with battery, IC engine based drone, any type of drones, so it is coming lesser than that, very significantly. You can see by the numbers and the life cycle also. So currently we were getting 367 hours of life cycle, which is significantly less, higher than any kind of battery power or any kind of power system drones. And the coverage which we are doing on per acre, like on per flight. So coverage we are doing of 8 acres in a single flight, which is significantly higher for any kind of drone which are currently available. And that is why we were able to provide this drone services to the Indian farmers at only 100 rupees per acre, which is really significantly cheaper than any kind of services, even if a farmers do by himself or herself. Not only this, we are also addressing the SDG goals like zero hunger, good health and well-being, like due to utilizing of drone technology, the exposure to the harmful pesticide we are eliminating, and also affordable and clean energy. So there is an also one utilization of our hydrogen fuel cell powered drone, that there is a extract of gas and water which come up from the hydrogen fuel cell. So those waters are in pure form. So those water can be utilized for the mixing of the pesticide, because in rural area the purity of water is not that much, and you need pure water to get 100% efficiency of any kind of chemical which is utilizing which was getting used in for pesticide spraying application. And SDG 9, with this hydrogen technology, we are also going to empower and to aware the rural area and the rural youth regarding the innovation what we had done. And this is also going to create a motivation for them to do something unique and innovative in their life. And also SDG 12, like the responsible consumption and the production, we were utilizing the highest bar and highest sort of per particle unit of pesticide spraying nozzles, which allow us to cut uh, 40% of the pesticide usage, which happen conventionally when you use manual spraying pumps. And also the climate, because these batteries were not recyclable, so they create at least 7.54 tons of carbon dioxide into the environment. They emit that level of carbon dioxide and this is just only one battery. So you can think at what scale this emission is happening. So that we are eliminating by utilizing green hydrogen, because green hydrogen doesn't emit any kind of carbon dioxide into the environment. It is one of the purest form of the hydrogen. And also the sustainable farming practices, like as we are going to utilize lesser amount of pesticide, we're going to increase the yield of soil organically, and also the ecosystem health by reducing chemical impact. uh, Me and my co-founder, I have done my graduation in computer science. I am graduated from SPSU Udaipur in 2021. And along with this, I have 3+ year of experience in cloud computing, AI, and software development. And also, I have a on-ground experience working as a drone co-pilot. And my co-founder, Mr. Hitesh Burana, who is the founder and chief operating officer of our organization. He has done his BTech in electrical, and he has done from CTAU Udaipur only in 2021 only. And he has 3+ year of experience in IoT, embedded system, and other electrical essentials. And apart from that, he has also having on-ground experience of flying drones especially agriculture drones, for more than 300 plus hours. So that is all from my side, ma'am. Looking forward from you.
Okay. Thank
If you
you,
have
Mr.
any
Vin.
sort
Yeah.
of questions or anything.
Yeah. Thank you for the short presentation. I'll now take up some questions. So first question is,
Yes.
hmm, what is the initial investment and how does the lifetime cost of green hydrogen drone compare to traditional battery powered drones or manual labor?
Sure. So our initial investment is bit of expensive because we had developed the whole hydrogen fuel cell in India, and we had done a research and development to make it a lightweight hydrogen fuel cell. So it has taken us around 8 CR of fund to do the research and development to develop this fuel cell. And apart from that, if you compare from the perspective of life cycle, so a battery powered drone can only exist up to 2 years maximum, but our drone can exist for 5 years. So that level of differentiation we are getting from the perspective of life cycle.
Okay. Uh, so next question is, what are the main agricultural applications of hydrogen powered drones?
So currently there are five applications. First is for the surveillance. Second is for the surveying of the lands. And third is for the maritime logistics. Apart from that, the pesticide spraying application, and also logistics supply chain into high altitude area. So these are the five applications.
Okay. And how cost effective are these drones for small and medium farmers?
Sure. So these are significantly cost effective for small and medium farmers, because currently they were paying 400 to 700 rupees per acre for getting pesticide spraying services from the battery powered drones and also from the conventional methods. But here we are only charging 100 rupees per acre from the pesticide spraying for the pesticide spraying services. And in this also, we are collaborating with the chemical companies so that 50% of the amount will be given by the pesticide company and 50% will be given by the farmers. So they only need to pay 50 rupees per acre. So it is significantly lesser than any other source of pesticide spraying services.
Okay. And since many of our farms are in remote areas, how will we manage the supply and storage of green hydrogen? Do we need specialized equipment on the farm to refuel the drone?
Yeah, yes, ma'am. So for that, we are collaborating with companies who are already into green hydrogen production, and also we are getting small scale level of hydrogen refueling stations, for which we had a sort of collaboration with a company based out in USA named Agastya Hydrogen, which were developing a micro hydrogen refueling station, which you can easily take into a four-wheeler, and you can refuel uh, by taking it anywhere, and you can refill within 5 minutes from 350 bar to 700 bars of gas.
Okay. And what is the continuous flight time of your hydrogen drone and how many acres can it realistically cover in a single day compared to the standard drone?
So our flight time is of 60 minutes in a single flight, and apart from that, our drone can cover 80 acres within a single day, which we have already tested. And from the perspective of comparison, battery powered drone can only do 20 acres of spray in a single day maximum.
Okay. And capacity, spraying capacity?
So we have a capacity of 16 kg, so 16 liter of pesticide our drone can take right now, and it can spray 8 acres within a single flight time.
Okay. And how safe is the use of green hydrogen technology in farm operations?
Green hydrogen technology is 100% safe because the standardization for the hydrogen tank were already there, and all the certification and the compliances which were required to utilize a Type 3 and Type 4 tank were already done by the manufacturers from whom we are procuring this hydrogen tank. So it is totally safe to utilize green hydrogen technology into the agriculture lands.
Right. Okay. And what role do insects and soil microbes play in supporting the food chain for birds? Sorry. By mistake, I asked. Sorry. What infrastructure is needed for hydrogen refueling and maintenance?
For the from the we need hydrogen refueling station hydrogen and hydrogen for which already guns and one to say as green and that is to fight say around 50 to 7. Sure.
Yeah. So, what infrastructure is needed for hydrogen refueling and maintenance?
For the station supply chain for which hydrogen production situated near from we are going to get hydrogen, green hydrogen, for which we are already in collaboration with the companies who are producing green hydrogen at a very so these three components were required, and from the perspective of maintenance, so much required because hydrogen tanks were very well manufactured and so much maintenance and refuels or also have a lesser amount of from the
Okay. So, next question is, can these drones help reduce fuel cost and carbon emissions in agriculture?
sure, sure.
Yeah. So, I was asking, can these drones help reduce fuel cost and carbon emissions in agriculture?
Absolutely, ma'am. So currently, the cost which is coming, it is of around 65,000 per kilowatt hour. We are reducing it to 22 rupees per kilowatt hour. So that is a significant level of cost reduction is there. And apart from that, the carbon emission, as I earlier mentioned in the slides also, each battery is emitting 7.54 tons of carbon dioxide into the environment. So that also we are eliminating with our green hydrogen technology.
Okay. And how safe is it for us to handle and store hydrogen canisters on the farm, and what safety features are built into the drone to prevent accidents during flight?
Sure. So we have integrated our fuel cell and hydrogen tank in that way that if there any damages is happening or any crashes were happening, so there is no impact happen on the fuel cell and the hydrogen tank. And from the perspective of hydrogen tank, it is very well safe because they have a three-layer of CCL, which is a industry standard. And even if you put the hydrogen tank into a burning fire, there is not a burst or any kind of blast it's going to happen. So, from the perspective of safety, it is very safe and very reliable.
Okay. And can this drone be used more than just spraying? For example, can it help with crop health monitoring or soil analysis using same hydrogen power system?
Yes, 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 yes. We have developed our drone in this way that you can easily swap the payload with other payloads in which you like multispectral camera and other sensors can be installed by swapping the pesticide tank, and it can be utilized for the crop monitoring and the soil analysis and different other applications also.
Okay.
Yes.
And one second. Okay. So, are there any government subsidies or support schemes from agri drone adoption?
Yes, already there is a scheme already been implemented by Government of India named Drone Didi, where 80% subsidy was given by Government of India for any kind of to any kind of SAG woman representative who wants to work as a drone service provider in the rural area. And also there are different loans and financial support schemes driven by individual bank institutions and individual state governments also.
Okay. And what are the major challenges in commercializing hydrogen powered drones?
So currently, one of the major challenges is the supply chain ecosystem because this green hydrogen supply chain system is already developing. We can utilize blue hydrogen and gray hydrogen, which is already in abundance, and also the unawareness of the green hydrogen technology and the hydrogen technology in the drone sector specifically because it's a new thing from the perspective of agriculture, agricultural adaptation of the technology. So these are the two major challenges which I feel like currently there. First is the supply chain unavailability, and second is the like the awareness, lack of awareness.
Right. Okay. And when can farmers expect these drones to become widely available and affordable?
Uh, Most probably within a span of 1 to 2 years, you can think that you can expect this technology will be available at a uh, large scale to the farmers.
Okay. So last question now. Because this
Sure.
technology is so new, what kind of training or local service support will your company provide in Rajasthan and if not Rajasthan, I mean, including Rajasthan, any other parts of India? And if the drone needs a
Mhm.
repair during the peak spraying session.
Sure. So, for this training purpose, we have a established training center in Jodhpur, Rajasthan, in association with Jodhpur Agriculture University and Redbird Flight Training Academy, where we are training farmers and also from the perspective of adoption of this new technology, where they are getting license to fly the drone commercially and also, apart from that, we are also training them to how to create their own drone as a service business ecosystem so that they can work up with us as a part of our organization.
Okay. So one final question, please let us know a little about your career background and what made you to start your company, Visron.
Sure. So, as I told you that I had done my computer science graduation, computer science and engineering graduation from Singhania University, which is situated in Udaipur. And I had 3+ year of working as a freelancer. I used to do freelancing for the companies for website development and other things. And since 2018-19 only, I was into this drone sector. Me and my co-founder, we had developed one of the first India agriculture drone also. And apart from that, in the robotic sector also, we both have worked formally in some organizations who were based out in Rajasthan only.
So what was the motive behind starting the company?
So the main motive behind starting this company is the solution to get the farmers this services at a very feasible manner. And the story runs back when I used to go with my mother. So my mother is a retired government servant from Agriculture Department of Rajasthan. So I used to go with her at her office, and I used to see so many farmers were coming there for the claims of their crop damages, and also some were getting affected through the chemicals. Some are died, and some are having skin and cancer issue. So I used to think that what can be a solution for that, and then after that, I have seen one of the shows which comes on the Star Television named Satyamev Jayate. So there I got to know that this issue is not only in my area, but it's across the country because I got to know about the cancer train which is running from Batinda to Bikaner because in Bikaner there is the cheapest uh, cancer treatment is happening, and there farmers used to come from Punjab, and majorly all the passengers who were traveling they are majorly farmers only who were affected by skin cancer, lung cancer, and different type of cancer. So this has given me a motivation to do something for the farmers.
Okay, that's very good to know, and it's a noble cause. Okay,
Thank you.
okay,
Thank you
Mr.
so much, ma'am.
Vinay. So
Thank you, ma'am.
I don't see any more questions. So now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for the presentation and answering all the questions, and wish you good luck for your future. Thank you.
Thank you. Thank you so much, ma'am, and to all the team and other members of Agriculture Information for giving us this opportunity.
You're most welcome. Thank you.
Thank you. Thank you.